Okay. All right. Okay. Okay. Hello, hello. Anyone watching? Yeah. Hello. Hope you're well. You are sure. Kali. So basically, all C programs start with this important this library hashtag include studio.h. This is the library that contains anything concerning input or output, taking input from users, displaying it to the screen. That's the library. Then, so here we are trying to create code the that can compute the roots of a quadratic equation. So basically, I had to initiate three functions to help me with that. That's basically the function for getting any number to a certain power. Yeah, there is only one instance where we need this, but I just had to do it to practice my syntax, to get to know the syntax well. So here, what I did was I created, oh, first of all, I had to define the function, the name, and the parameters it will take. That's x and y. From there, I had to initiate z1. After initiating z1, what I did, I used a for loop to help me get the value of x after it has been multiplied y times. Okay, yeah, so basically I initiated my I as a counter to 0. Then I said for as long as the condition is for as long as I is less than y, which is the number of times I want to multiply x to itself, for as long as I is less than y, increment I by 1 and also multiply x to itself. And then when I ceases to be less than y, return that value of z. So basically, if we have something like a 5 here, then we have something like a 3 here, which is 5 cubed, we shall have, it will come the first time when I is equal to 0, look through, I is less than y, because I is 0, this here we have 3, so it will increment that, multiply 5 times 5, that's 25, comes here, looks here, I is equal to 1. It will continue that until it reaches, of course, 3, so 5 cubed is 125, so this will obviously, well, this is a function to help me get the exponent. Then the function for getting the square root function, I called it get square root. Oh, sorry. Well, before I go any further, there's a word here, double, which you can see I've used it a lot in my code. So double is another form of data type that basically it's the same as float. You know, float is also a data type, but double is like float. The only difference is float can only allow you to store a maximum of let's say like 4 digits after the decimal place. It can store a maximum of, it can only store digits that have 4 digits after its decimal place. That's float. But double can let you store up to 8. So the reason that's why I'm using double is because it allows you to use it allows you to use a wider range of values than float. So that's why I'm using double. So here we have getting the square root. Getting the square root, basically what we do have is it takes in a parameter of the number of square root we want to find. Then here we create an location in our memory where the variable I will be stored. Then we give I 0.001. The reason that's why I gave I 0.0, a value of 0.001, it's because I want our square root to be corrected to at least 3 decimal places, just for improved accuracy. So from here, what happens is, this is the condition. For as long as I squared, which is this squared, is less than x, once we square this value and it's less than x, just increment I by 0.001 and do that until I squared is not less than x. Because once it ceases to be less than x, then that basically means I is the square root. So from there, return I. That is after I squared is no longer less than x. From there, we create a function to get the discriminant. Which is basically b squared minus 4ac under root. So from here, I had to first get the value of 4ac, which I gave to c. I gave it a variable c, which already exists, of course, but we just update it, which is 4 times a times c. Then store that in c. I told the program to store that in c. From here, I called my get exponent function, where I want to get the exponent of where I wanted to get the value of b squared. Of course, someone else would have done this manually, which is just b times b. But as I said earlier on, I'm trying to learn the syntax of the language. That's why I used this function of get exponent b to. So here, this here is equivalent to having b squared minus c, but our c is 4ac. So this is b squared minus 4ac, and return a c, which is our discriminant b squared minus 4ac. So all these are the functions that I've used in my code. There are only 3. Yeah, some of them there are better ways of dealing with them. Others, yeah, either way. But that was my way of dealing with the problem. So here we have our main function, which enables us to get. Here, obviously, I had to get input from the user. I had to first create storage space for the 3 variables that I need from the user. Afterwards, I prompted the user to enter the value for a, and the scanf function helps me to read the value of a and store it in memory. But then in the question, we are not supposed to let the user have feed in a value of a that's equal to 0. So basically, that's the purpose of this if else statement that I included. So I said if the value of a is equal to 0, just print not a quadratic equation, please try again, and stops there. But if I added, the else part, I just put the rest of the code that's supposed to be executed, I threw it inside the else part. So if he puts in any value that's not 0, it will just come and execute the rest of the code, the rest of this code here, up to down. Yeah, up to down here. But if he put in a value that's 0, the code would just stop here. Yeah, so we shall look at that in the end when I do a sample run. Yeah, from here, we continue. Okay, where was I? Yes, here. The else part. The else, after the user has put in a value that's not equal to 0, what happens is he will have to put in a value for b. He'll have to put in a value for b and a value for c as well. A value for c. And all these will be stored in the memory locations which I reserved at the start of the program. From there, I'll use my get discriminant function, to get the discriminant for the quadratic equation, which is b squared minus 4ac. And then afterwards, I will get the square root of the discriminant, because here I assigned it a variable discriminant. So I get the square root of the discriminant, where I called my get square root function to get the square root of the discriminant, and then store the value in j. From there, I use my if statements to bring out what you had said, what was in the question, which is that if the roots are real and distinct, they should be printed to the screen. If they are real and equal, they should be printed to the screen. And then if they are complex, it should just say complex roots. So from here, if the discriminant is greater than 0, whereby the discriminant, what happens is in quadratic equations, the reason as to why we always have 2 values is because of that square root sign. Once whatever is under that square root sign totals up to a positive, that basically means the square root of any number, of any positive number, is a negative and a positive. That's why we have 2 values. So once the discriminant is greater than 0, that basically means we shall have 2 values for the roots. That's why Here I had to deal with negative b plus j, whereby our j is the square root of the discriminant. And then I had to deal with negative b minus j, which is our second value of the square root. Then I divided all that by 2a and returned the results. And I returned the results in this print statement, which says the equation has real distinct roots, which are whatever the user will have put in. Else, if, this is the other option, if the discriminant is equal to 0. So obviously once the discriminant is equal to 0, that means the square root of 0 is a 0. So we can't have two values. We shall have one value. That's why we shall end up having one value for the root, which are actually equal roots. So basically from here, I just continue. I said after we have gotten our j, which is the which is the square root of the discriminant, what happens? I just add j to negative b, and then I divide the result by 2a, and then I print the result to the screen. I print the result to the screen. Yeah, and obviously the print statement will say the equation has real and equal roots. It's better if I think it's better if I say real equal roots. Has real equal roots that are that and that, which will be similar. Then obviously if the discriminant is not equal to 0 and it's not greater than 0, it has to be less than 0. And from our O-level mathematics, we know once the square root of a negative number gives us a complex number. So here obviously we shall have complex roots, and that is the code. So maybe let's do some simple testing. There is a quadratic equation that I have here, which is x squared minus 5x plus 6. Its roots are 2 and 3. So basically, let's give it a simple try. First we have to, first we have to switch to start. Okay, then we switch to and then we switch to data structures and algorithms. Yeah, from here I have to compile my code, which is GCC. This is solid.c. Store it in an execution type solid. Then I can execute it by saying so here my quadratic equation is x squared minus 5x plus 6. So the coefficient for x squared is 1. The coefficient for x is negative 5. And the coefficient for x to the power 0, which is the value that is normally a constant, is 6. So once I press enter, I'm supposed to have two roots, which are 2 and 3. See, it returns it here and says the equation has real distinct roots, which are 2 and 3. Thank you for watching. Have a nice day. Yeah.